It is not acceptable to use a 50 amp breaker with number 8 wire for a 40 amp load on an AHU, or air handling unit. There are several reasons why this is not acceptable. Firstly, this situation constitutes a code violation. The National Electrical Code, or NEC, mandates that the circuit breaker or fuse rating must not exceed the ampacity of the wire. Number 8 American wire gauge copper wire, when using the 75°C column found in NEC Table 310.16, has an ampacity of 40 amps. Therefore, the maximum circuit breaker rating should be 40 amps. Employing a 50 amp breaker directly contravenes this fundamental code requirement. Secondly, using a breaker that is too large for the wire creates a significant safety hazard. A circuit breaker is engineered to trip, that is to say, to interrupt the flow of current automatically when the load exceeds its rated capacity. This tripping action is a protective mechanism intended to prevent overheating and potential fire. When the breaker rating surpasses the wire's ampacity, the wire lacks adequate protection against overcurrents. Consequently, the wire can overheat, melt its insulation, and ignite surrounding materials, leading to a fire. This risk is substantially amplified when a 50 amp breaker is used with wire rated for only 40 amps. Thirdly, there is a considerable risk of equipment damage. Overcurrent conditions stemming from the use of an oversized breaker can inflict damage on the AHU itself and any other electrical equipment connected to the circuit. The excessive current can overload the equipment's internal components, causing them to fail prematurely or malfunction. Such damage can result in costly repairs or even the complete replacement of the affected equipment. To remedy this situation, immediate corrective action is essential. The 50 amp breaker must be replaced with a 40 amp breaker. This ensures compliance with the National Electrical Code, mitigates safety hazards, and provides adequate protection for the air handling unit and associated electrical equipment. In addition to the fundamental code compliance and safety considerations, several other factors merit attention. It's possible that the original plans specified the incorrect breaker size. Plans, particularly if they are outdated, may contain errors. It is always crucial to adhere to the latest edition of the National Electrical Code and any applicable local codes. Furthermore, the breaker must be appropriately matched to the specific electrical specifications of the air handling unit. The AHU nameplate will typically indicate the required overcurrent protection device rating. Regular maintenance and inspections are indispensable for ensuring the ongoing safety and reliability of electrical systems. These inspections should be conducted by qualified personnel and should encompass a thorough examination of all circuit breakers, wiring, and connected equipment. Any signs of wear, damage, or overheating must be promptly addressed. To delve deeper into the specifics of wire ampacity and breaker sizing, consider the following points. The ampacity of a wire, that is the maximum current carrying capacity, is influenced by several factors, including the wire gauge, the type of insulation, and the ambient temperature. The National Electrical Code provides detailed tables, such as Table 310.16, that specify the ampacity of various wire sizes under different conditions. Always consult these tables to determine the appropriate wire size for a given load. When selecting a circuit breaker, it is essential to choose one that is sized correctly to protect the wire and the equipment it serves. The breaker should have a rating that is no larger than the wire's ampacity, but it should also be sufficient to handle the normal operating current of the equipment. It is permissible to use a breaker that is slightly larger than the equipment's rated current if necessary to accommodate motor starting currents or other temporary overloads, but the breaker should never exceed the wire's ampacity. Also consider the breaker type. There are different types of breakers available for different applications. For example, some breakers are designed to trip quickly in response to short circuits, while others are designed to trip more slowly in response to overloads. Choose the appropriate type of breaker for the specific application. When working with electrical systems, always prioritize safety. To energize the circuit before working on any electrical components. Use appropriate personal protective equipment, such as gloves and safety glasses. If you are not comfortable working with electricity, hire a qualified electrician. Moreover, ground fault circuit interrupters, or GFCIs, are essential safety devices that protect against electrical shock. GFCIs should be installed in areas where there is a risk of water exposure, such as bathrooms, kitchens, and outdoor locations. Arc fault circuit interrupters, or AHUs, are another type of safety device that protects against electrical fires. AHUs detect arc faults, which are dangerous electrical conditions that can cause fires. AHUs should be installed in bedrooms and other areas where people sleep. Surge protective devices, or SPDs, protect electronic equipment from voltage surges. SPD should be installed at the service entrance and at individual equipment locations. Proper labeling of electrical panels and circuits is crucial for safety and troubleshooting. Clearly label each circuit breaker with the corresponding load it serves. Keep electrical panels clean and free of obstructions. Regular inspections of electrical systems are essential for identifying and addressing potential problems before they become serious. Inspections should be conducted by qualified personnel and should include a thorough examination of all circuit breakers, wiring, and connected equipment. In addition to these technical aspects, it is also important to consider the human factors involved in electrical safety. Training and education are essential for ensuring that workers are aware of the hazards of electricity and how to work safely. Encourage a culture of safety in the workplace where workers are empowered to speak up about potential hazards. Investigate all electrical incidents and accidents to identify the root causes and prevent future occurrences. By implementing these measures, you can significantly reduce the risk of electrical accidents and injuries. Furthermore, consider the specific application of the AHU. Is it a residential AHU, a commercial AHU, or an industrial AHU? The electrical requirements may differ depending on the application. For example, commercial and industrial AHU may require more robust wiring and overcurrent protection than residential AHU. It is important to consult the manufacturer's specifications for the AHU to determine the specific electrical requirements. In addition to the AHU itself, consider any other equipment that is connected to the same circuit. Are there any other loads on the circuit? If so, the circuit breaker and wiring must be sized to accommodate all of the loads. It is important to perform a load calculation to determine the total current draw of all of the equipment on the circuit. The load calculation should take into account the continuous and non-continuous loads. Continuous loads are loads that operate for 3 hours or more at a time. Non-continuous loads are loads that operate for less than 3 hours at a time. The National Electrical Code requires that continuous loads be multiplied by 125% when calculating the total load. This is to account for the fact that continuous loads can cause the wiring to overheat. Once the total load has been calculated, the appropriate circuit breaker and wiring can be selected. The circuit breaker should have a rating that is no larger than the wire's ampacity, but it should also be sufficient to handle the total load. The wiring should be sized to carry the total load without overheating. In addition to the load calculation, it is also important to consider the voltage drop in the circuit. Voltage drop is the decrease in voltage that occurs as electricity flows through a wire. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The National Electrical Code provides guidelines for limiting voltage drop in electrical circuits. To minimize voltage drop, use larger wires or shorter circuit lengths. Also, ensure that all connections are tight and free of corrosion. Proper grounding is also essential for electrical safety. Grounding provides a path for fault current to flow back to the source, which helps to trip the circuit breaker and prevent electrical shock. All electrical equipment should be properly grounded in accordance with the National Electrical Code. The grounding system should be inspected regularly to ensure that it is functioning properly. In addition to these technical considerations, it is also important to consider the environmental conditions in which the electrical system is installed. Is the system exposed to moisture, dust, or corrosive chemicals? If so, special precautions may be necessary to protect the wiring and equipment. For example, corrosion-resistant wiring and enclosures may be required. Also, ensure that the equipment is properly ventilated to prevent overheating. Proper documentation of electrical systems is essential for troubleshooting and maintenance. Keep accurate records of all wiring diagrams, circuit breaker schedules, and equipment specifications. This information will be invaluable when troubleshooting problems or performing maintenance. Also, ensure that all electrical work is performed by qualified personnel. Electrical work can be dangerous, so it is important to hire a qualified electrician who is familiar with the National Electrical Code and other applicable standards. Furthermore, follow all safety precautions when working with electricity. To energize the circuit before working on any electrical components. Use appropriate personal protective equipment, such as gloves and safety glasses. And never work on electrical equipment when you are tired or distracted. By following these guidelines, you can ensure the safety and reliability of electrical systems. Remember, electrical safety is everyone's responsibility. Always be aware of the hazards of electricity and take precautions to protect yourself and others. In summary, when addressing the issue of using a 50 amp breaker with number 8 wire for a 40 amp load on an air handling unit, it is crucial to prioritize safety and code compliance. Replacing the oversized breaker with a properly sized 40 amp breaker is not only a code requirement, but also a fundamental safety measure that protects against fire hazards and equipment damage. Regular maintenance, inspections, and adherence to the latest electrical codes are essential for ensuring the long-term reliability and safety of electrical systems. Moreover, consulting with qualified electricians and adhering to manufacturer's specifications are crucial steps in maintaining a safe and compliant electrical installation.